Hello and welcome to another video on geology. This video will be on sedimentary rocks. In the previous videos we discussed the process of sedimentation, where particles are deposited into layers. We will now talk about how this process will lead to the construction of three different kinds of sedimentary rock. Please divert your attention to the left side of the board. Clastic sedimentary rock. Because it is caused by weathering down of other rocks, possibly igneous rocks, it is also known as weathered sedimentary rocks. And the deposition of this, the way it's deposited affects its structure. It is deposited, direct your attention to the bottom, in layers. The grains are cemented together, possibly through gypsum or other minerals. And it is compressed so that you get essentially the structure, and you can see a band structure. Now divert your attention to the middle of the board, chemical sedimentary rocks. Chemical sedimentary rocks are not caused by the weathering of other rocks, but rather sometimes solutions. This could be water, for instance your ocean, and your solutions have dissolved compounds. In the ocean, there are many different kinds of compounds dissolved. So it's possible when your water evaporates, the compounds that are dissolved will begin to crystallize, and they will crystallize out of the solution. Divert your attention to the bottom, this diagram. I'm just basically trying to model the idea that there is an ocean, the ocean floor. As the solvent, your water, evaporates out, your solute, the compounds dissolved, will begin to crystallize at the bottom. Over time, your solute layer will build up, and again it is layered, but it is layered through a different process. It does not contain clastic material. It contains material which was originally dissolved in your solution. Now divert your attention to organic sedimentary rocks. I'll switch sides. Organic sedimentary rocks are created by dead plants or animals, accumulated and again cemented, possibly through gypsum as well, but usually rarer because gypsum is a mineral contained in igneous rock and is not very common in, per se, human bodies or plants. Those are the only definitions you need to know. But geology requires you to apply this to the understanding of rocks. So you actually need to see this in practice. Okay, so in my first video I talked about granite. And I talked about how granite was constructed by the minerals feldspar, mica, and also quartz. Over time, as weathering occurs, the quartz will break down and form something that's similar to sand. And the layering of sand being compressed and being cemented together will form something called sandstone. Sandstone is a clastic sedimentary rock. However, the feldspar, that just weathers away and becomes like your glue, or just gets taken away, eroded to some other place and breaks down to very, very miscellaneous other compounds. Feldspar is a very complex compound. Your mica will also weather away and break down to something else. Depending on how it is layered and the different sizes of the grains that it breaks down into, it can form possibly mudstone. I don't have it on me, but if the grains are much more common, then instead of it being mudstone, it will be called siltstone. If there are almost no grains, then it will be called claystone. Clay is a product of mica. one technique to determine the size of the grains is to put on a microscope, but sometimes it is difficult to see. Another technique is to put it in your mouth and just try to grind your teeth over it. If it feels gritty, then you've got some kind of grains there. If it feels chewy, then you've got some kind of clay there. And the degree of chewiness and grittiness determines what kind of label it is. But again, these are all made from mica, and possibly all from granite. Not definitely, because mica might be in other igneous rocks as well. Moving on to chemical sedimentary rocks. One example, calcium carbonate, is limestone. Limestone essentially is the buildup of calcium carbonate in your solution, in your ocean. And it's actually formed by dead animal skeletons actually. But it does dissolve into the ocean and it basically will collect up again. There is a term of sedimentary rocks which bridges the gap between chemical and organic, which we call biochemical. This course does not technically investigate it, but for your own sake, you know that chemical and organic, there is no clear boundary. It is a continuous boundary. And things that are chemical can also be organic, and things that are organic can also be chemical. For instance, limestone. And going lastly to the organic sedimentary rock, we have coal. Coal is dead plants from swamps possibly being covered by layers and layers of silt. You compress it and these particles cement together and it forms this black but slightly shiny substance. If you burn it, you get your energy back. Coal. Plants. Now the confusing thing is, not that you have degrees of clastic sedimentary rocks, or degrees of this, or degrees of organic sedimentary rocks, is that sometimes in clastic sedimentary rocks, you also might find a dead animal. Or in organic sedimentary rocks, you might also find clastic sediments, so broken up rocks. It's not very likely you'll find a pure substance. And those very small deviances in what makes up or how this sedimentary rock was essentially constructed, how the layers were deposited, can affect its substance quite dramatically. I have another piece of limestone, and as you can tell, compared to my first one, it looks completely different. They're both limestone, calcium carbonate. And here I have a piece of, I think it's mudstone, but I'm not 100% certain. But if you look at it very closely, you can see that there is prints of some kind of shellfish or some organism that was alive in this bunch of sediments. That's quite amazing. In a clastic sedimentary rock, there is organic substances, although they probably died and were absorbed somehow. But nevertheless, part of this was constructed, very mildly though, constructed by organic matter. So to conclude, 3 different kinds of sedimentary rocks, and they're all constructed slightly differently. But then again, there is a combination of each other within themselves. And these sedimentary rocks are formed from other rocks that have been weathered, eroded, then deposited. I hope this was helpful. See you guys next time.